is a logical argument that shows a statement is true. So a logical argument that shows that a statement is true. So for our reasons of proof, we're going to quickly do some brainstorming on the different, I'm not talking to you right now. Figure it out.
Does anyone have a pencil I can borrow?
Look behind you. Are there writing utensils behind you? So,
The thing is empty.
there are color pencils, there's markers all over there. Reasons for proof.
You okay with a pen? No, I'm gonna get a pen. Keep it.
We've talked about the angle addition postulate before.
Who brought Siri to class?
Okay. Postulate. We've got all the other properties that we've talked about, which I'm not going to write those down again because we have them in our previous notes. So addition property, subtraction property, multiplication property, division property, substitution property, and the distributive property of equality are all of those.
What the heck is that?
What did I just say?
No, there's a...
What did I just say?
Sorry.
So these are your two postulates. So anything that's not a postulate or a property needs to be written as an if-then statement. So if it's a property, then you would just say addition property. If it's a postulate, you would just say segment addition postulate. But if it's not a property or a postulate, if you think about your two columns for your proof, over on this right side, these would be the things that you're going to be writing, your reasons. Because remember, it's statements and then reasons. So let's go through a few if-thens. If a point is a midpoint. Is everybody okay with me abbreviating PT for point? Yes? So if a point is a midpoint, what happens? What's the conclusion?
It's in the middle of the line.
More specifically,
Divides the line into two
yes. I'm going to say then it creates two equal segments. Okay, so if a point is a midpoint, then it creates two equal segments, or divides it into two equal parts. Okay, what about if a line is a bisector? What happens if I have something that's a bisector? Then what? Something is bisected. What does that mean? Yeah, it cuts it in half, or it creates two equal parts. So then, it creates two equal, and I'm going to put segments, then I'm going to put a slash and then write angles, because depending on if it's an angle or a segment being bisected is what you're going to put here. If I had an angle being bisected, then it would create two equal angles. If it was a line or segment being bisected, then it would create two equal segments. Does that make sense? Depending on what it is you're talking about, you're going to use the appropriate context. All right, how about this one? If two angles are a linear pair, bless you, then what? Thank you for raising your hand. What's your answer?
It's either they equal 90 degrees or they equal 180
Well, think
degrees.
about a linear pair.
They are next to each other.
And they create what? They create a line.
Oh,
How
yeah.
many degrees are in a
And
line?
they create 100 degrees and
Right.
180 degrees.
So then they are supplementary. Two more bullets. So if two angles are supplementary, then what? Then they add up to 180 degrees. What do you think our last one's going to be? Dominic?
If they add 280 degrees, then it is a straight line.
Nope, we're done there. We did supplementary angles, so now we would do, what's the other one? Complementary. So if two angles are complementary, then they add up to 90 degrees. Okay? We eventually are going to get to where we have a whole sheet of paper of different reasons that we could possibly have for proofs. This is just a good starting point. Okay? For today, the angle addition postulate and the segment addition postulate are going to be your favorite ones to use because they're going to be the ones that are going to help you get to what it is you need to do. All right, so we've got a bunch of proofs that we're going to finish for notes today. So let's go ahead and get ourselves set up with the first one. Make your T-chart. Statements on the left. Reasons on the right. For any proof, we should always start with what?
Given.
The given. So line 1, we have the measure of angle CBE equals the measure of angle DBA given. All right, well, let's look at the diagram and see what this really is telling us. Bless you. The given is telling me that angle CBE is equal to angle DBA. So those two angles are equal, right? That's what they're telling me. Now let's look at the given. This is where we want to get to. I want to prove that the measure of angle EBA, so EBA, which is here, I want to prove that that is congruent, bless you, to, a little yellow, to angle DBC, which is here in yellow. So I need the blue, bless you, to equal the yellow. How do I get there? So this is what I always think of. Look at the prove line. Remember, your prove line should always be your last line. Once you hit that prove line, then you are done. In my prove line, I'm talking about angle EBA. Do I have EBA in my proof somewhere on the statement side? Does this line have EBA in it? No. So I need to introduce angle EBA somehow into my proof in order to get EBA into the prove line. To introduce it, I'm going to use angle addition. So if you ever get to a point you're like, well, that tells me that those two are equal, I don't really know where else to go, think about your angle addition postulate. So look at EBA. If I think about my segment or my angle addition, the measure of angle EBA, so it's the blue one up there, is equal to what two angles added together? Yep, Perfect. So it's equal to the measure of angle EBD plus, save it for later, the measure of angle DBA. Angle addition postulate. Okay, so now I did get the measure of angle EBA into my proof, which is good because I need it to be there because somewhere down here I'm going to need to say that this is equal to DBC. Well, I don't have DBC in my proof yet, so I need to introduce it. So whenever I need to try to introduce something into it, I'm probably going to be using either angle addition or segment addition. Well, let's do the same thing, but do it for DBC. So line 3. The measure of angle DBC would be equal to what two angles added together? Yeah, I went EBD first. Plus CBE. So CBE. And just use ditto marks, unless you want to rewrite angle addition postulate again. That's up to you. All right, so now, do I have the two things in my proof in my statements? Yes, it's right here and it's right here. I need to prove that these two things are equal to each other. Well, in order to prove that these two things are equal to each other, so if the lefts need to be equal, then I need to make the rights equal. Are my rights the same right now? When I say rights, I mean the right side of the equal sign. Well, look on the right side of the equal sign here. Here you have a measure of angle EBD. Here you have a measure of angle EBD. So far we're the same. But here I have a measure of angle DBA, and here I have a measure of angle CBE. Are those the same? No. I need to make them look the same, and I can do that by using the substitution property. Look up here what we wrote.
They are the same.
Look what we wrote up here in line 1. Didn't we say that they are equal to each other? So can't I use the substitution property, and don't do this in your notes because you can't erase it. Can I substitute CBE for DBA? And then it would be the same thing, right? But I need to show that in my step. So line 4, what was this? CBD. CBE. Line 4, I'm going to rewrite line 3 exactly the same, except for substituting in that one change. So the measure of angle DBC, that stays the same. The measure of angle EBD, that stays the same. But now what am I going to substitute in place of CBE? DBA, good. And that was our substitution property. All right, we're almost there. So now, ignoring line 3. 3's out of the picture. I don't really care about it anymore. All I needed for 3 was to get to 4. Look at line 2 and line 4. Now does the right side of my equal sign match up with the right side of the equal sign before 2 and 4 together? Yes. So what property allows me to take out the middle link and be left with the first and the last? Think of last week. What property says, again, don't put this in your notes, what says I can take out this part and then just be left with, change my color, left with just those two things. Take out the yellow, you'd be left with the green. We just talked about those 3 before we started the notes. Which one of those 3? Reflexive, symmetric, or transitive?
Transitive.
Transitive. Says you can take out the thing that they have in common and you're left with that. So line 5 then tells us that the measure of angle EBA is equal to the measure of angle DBC because of the transitive property. Did I find the prove line? Is that what I needed to prove? Yes, so now I am done. Okay. So proves. You have to write out all your thought process down into a logical argument to prove why something is the way it is. All right, flip on to the back. We're going to do 3 more. Set it up. Make your T-chart. Statements on the left. Reasons on the right. Everyone should always be able to write out the given. So we are given that AC is equal to AB plus AB. Given. Okay. AB plus AB is equal to AC. I need to prove that AB is equal to BC.
You can tell it is.
Well, we got to prove it. So let's look at what they give us. Here I have AB. I'm going to need to get AB somewhere in my proof. Do I have AB somewhere in my proof already?
Yes.
Yeah, I've got 2 of them right here, so that's great. Somewhere I need to get a BC. Do I have a BC somewhere in my proof? No, so I need to introduce that BC. And to introduce it, we're going to use segment, because we're dealing with segments, addition postulate. Well, what does my segment addition postulate state? What's equal to what plus what? I'll help you out. AC is equal to what plus what? AB plus BC is what the segment addition postulate tells us. So segment addition postulate. Okay.
Why isn't the segment addition property?
Because it's not a property, it's a postulate. It's something that has never been proven, but we say that it's true. All right. Look at line 1, look at line 2. Notice what's happening on the left side. These are the same. So if these are the same, what can I do with those 2 things? Do I want to take out the green or do I want to take out the yellow? Nolan?
Green.
Take out the green. So if I take out the green, then I'm left with the yellows. AB plus AB is equal to AB plus BC. Which property was that? Perfect. Transitive property. I feel like I spelled transitive last time wrong. I feel like I put an A in there. Transitive. Transitive. Did I spell it wrong? I think I did. Who sees it? One more step.
Well.
How am I gonna get from here to here? Let's let everyone else think. Here to here.
Could you provide us with A and B?
That's what everyone else was thinking, wasn't it?
Let's not say subtraction.
Subtraction property. Perfect. If we subtract, and I'll physically show it, if we subtract an AB from both sides, then we've got AB is equal to BC, which is the subtraction property. And is that what I need it to prove? Yep, so we're done. Beautiful. Isn't it just so magical how it works? It's magic. I love proofs. Like when you get to the end, you're just like, wow, it worked out so nicely. All right, 2 more. Set it up. So this one gets a little bit more work. You might want to put a star next to this one because this one's similar to one that you're going to have to do for your homework. M is the midpoint of line segment AB. Given statements. reasons. Okay. M is the midpoint of AB. Here our given does give us some extra information. In the other problems, it just kind of gave a blanket statement and said this is equal to this. This is equal to this. Here it's giving us a little bit more detail. It's telling me that M is the midpoint of line segment AB. So if M is the midpoint of line segment AB, where are your two equal parts? If M is the midpoint of AB, where are your two equal parts? Yeah, right? That's the middle. Doesn't that equal that? So let's write that. So number 2, let's say that AM is equal to MB. Because that's what we get from this. We get that is equal to that. So now what do I write on the other side? Save it for later. I didn't answer your question yet. Maybe I will.
No, it's about the line itself. Why is the B bigger than the other ones?
Because when I made the diagram, I probably copied it and it was bigger B.
Oh.
I had to make all these myself. All right, so is this a postulate or a property?
Postulate?
Is a segment addition postulate? Is the addition angle addition? Is it subtraction addition, multiplication, division, subtraction, or substitution? No, it's not a property, so that means I need to write an if-then statement. And the beauty of your if-then statement is what follows. Your hypothesis comes from the previous line, and your conclusion comes from the line that it follows. So what are we talking about? If a point, M is a point, right? If a point is a midpoint, then it creates what? Two equal segments. Well, that's what we're going to write over here. If a point is a midpoint, then it creates two equal segments. Now, if this had congruency in my proof line, that was a congruent symbol and not an equal symbol, then I would turn this into two congruent segments just to keep with the notation. But since it's an equal sign in my proof, I'm going to stick with an equal sign. So that can interchange with whatever it is the problem's talking about. Okay, so far so good. So now we got an AM. Notice I have an AM here. But what else is in my proof? An AB. Do I have an AB here? Do I have an AB here? Not kind of, but not really AB. That's just talking about the segment. How am I going to introduce AB? Not yet. How have we introduced everything else in the past few problems? Nope. Not AC. AB is equal to what plus what? AM plus MB. What's our reason? Why can't I do that?
Additional.
Yeah, segment addition postulate allows us to do that. Okay, now we're someplace. Now I've got an AB in the game. Bless you. I've got an AM and I've got an AB. So I need to somehow get just AMs and ABs in this line. How do I get just ABs and just AMs?
I know.
How?
You would. I thought you would get rid of the M's in both of those, but I guess maybe not.
Nope, I can't just get rid of M's.
Maybe because there's two M's, I thought you could get rid of them.
Nope. What's the only thing in this line that is not A, B, or A, M? Ashley?
MB, so you would use the subtraction.
Not subtraction,
Division.
not division.
Okay.
Substitution. Can I substitute AM in place of MB because they're equal to each other? Yes? Okay. So, line 4, let's do that. So I'm going to rewrite line 3, but instead of MB, I'm going to turn that into AM. Substitution.
Wait. So MB is equal to AM. Oh yeah. It is.
Yeah. Okay, almost there. So somehow I need to get a number. Right now I have 1/2. So somehow I need to get a number into this line. Well, what's 1 AM plus 1 AM? 2 AMs. So then I get AB is equal to 2 AM. What's that property? Guesses? Ashley? Not a simplify. Distributive, yeah, that's the distributive property. What's our last one? How do I get 1/2 of AB is equal to AM? Division, good. There's our last step. I think for your homework, it's either 23 or 24. I don't remember which one it is. I think maybe 23. It's very similar to this, but they have you stopping.
It says 25.
Okay, so maybe it's 20. Nope, for geometry, 23 and 24 in black.
I'm not good. No, that's a 5. Yeah, I don't understand. Oh, no.
That's a 3.
It looks
So 23, I think it makes you go to line 5 and not go one extra step. So you might want to put a star next to that to help you get through the homework. All right, last one. Set it up. Should be no reason why any of your proofs will be blank, because you all can make a T-chart. You all can write statements on the left, reasons on the right, and fill in your given. Given. Okay, look at that proof line. I need a WX. Do I have a WX in my proof someplace?
Yeah.
I already do. No, we need to get it in there. How can I get WX into my proof? How have we introduced anything into our proofs? Segment addition. What's it going to look like for my segment addition? I want to incorporate WX. So notice WX is right here. Well, I can't do WX is equal to 2 things added together because WX is not equal to 2 things added together. But what can I do for segment addition? That helping anybody?
Wait a minute.
Yellow plus blue equals what?
Yeah,
Yeah.
yellow plus blue equals green.
So WY is equal to WX plus XY, segment addition. Postulate. All right, we got WY into the mix. What else do I need to get into the mix? YZ. How am I going to get YZ into the mix?
XY plus Y, Z. Wait, no.
So XZ is equal to what?
XY plus YZ.
Good. XY plus YZ. Just ditto mark it, unless you want to rewrite it. Segment addition postulate. Okay, then let's make the magic happen. I need to get WX which is here, to equal yz. Okay, so how can we do that? I need to get this equal to this. Which means, for that to equal that, I need to get everything else to equal each other. Well, does this equal this?
Yes.
Yes. X, Y, and X, Y are the same. So we got the right sides the same. Do I have the left sides the same?
No.
Does this equal this? No, but can I make this equal this?
Mm-hmm.
Yes, by using what property? Not transitive yet. Substitution, right. So I'm going to rewrite line 3, but instead of
What the heck is that?
xz, it's okay.
Keep that thing away from me.
We're going to rewrite it wy is equal to xy plus yz. Dominic, do you need to go in the hall?
I'm not, that thing is huge.
It's probably just a stink bug. It's fine. All right, so substitution property just occurred. Okay, we're almost there. What can we do? Look at 2 and 4. So now I've got right side, and I've got left side. What do we want to take out? The orange or the blue?
So,
Do I want to show that wy equals wy?
No.
No. So I want to take out the orange and have the blue left over. So wx plus xy is equal to xy plus yz. Which property is that? Took out the link. Transitive. Almost there. What's the last step? Look at your proof statement and look at what we have. Which property? Subtraction. Perfect. So subtract. So subtraction property will allow us to subtract an xy from both sides to be left with wx equals yz. Done.
What if you have one that
yeah, what is the thing where...
They should work out, so you need to
What if they
revisit.
don't though? What if they just
Then
give you
the
a
book
They
is
won't
wrong.
give you one that won't work
Then the
out.
book is wrong.